The first time you load a game, it's significantly longer than subsequent launches. Is it possible to create one big, gigantic master material and create different branches inside it? All of these branches, all of these switches, they create additional shaders. And this here isn't quite right. This is also a mistake. Because each channel stores separate information for ambient occlusion, roughness, and metallic. We can use a break node to split it into 3 channels and use them to put this topic to rest once and for all. First of all, we need to understand what master materials are. Master materials are the main materials or templates that we can use to create copies. There's no magic bullet, so I'll try to explain it using the example of large studios, using a competent, structured approach to put this topic to rest once and for all. In what cases should you use it? For this material, we use instances. We use them. Why? Because we have parameters in our instances, and we can change them in real time. In real time, we can adjust certain values, colors, sizes, and so on, meaning we're updating information in real time. And we like that, because we don't have to go into the main material and wait for shaders to compile and so on. This brings up a question. The first time you load a game, it's significantly longer than subsequent launches. Meaning, the first time you launch it, it takes longer. And when an update is released, this shader compilation starts all over again. So look, in some cases, the developers themselves will kindly tell you, compiling shaders, please wait, which means the shaders need to be compiled, and they need to be compiled once. That's exactly what we do in the master material. We create it, hit apply, and we've compiled it. So the shader is compiled, but instances don't compile shaders. They take the already compiled shader from their parent material, their template, and then just change some values based on it, okay? That's the difference. Now for the question, what's convenient for us, what's useful for us, and what does Unreal Engine, the engine itself, prefer? The first thing we need to understand is a concept called the balance between quality and performance. We want the absolute best of everything. We want beautiful quality, we want everything to be convenient and flexible, we want to update information quickly in real time. In short, we really want it all, absolutely everything. And Unreal Engine, well, it's actually a lot like us. It's also kind of lazy in its own way. So what in general does Unreal Engine actually require from us so that it can in turn give us what we're demanding from it? As a reminder, we demand flexibility, we demand optimization, we demand a lot of things, a whole range of different features and capabilities, really. So what Unreal needs from us is as little information as possible. And by information, I mean everything. Fewer nodes, fewer functions, less of everything. The less of it there is, the faster Unreal processes the information. That's the first thing. And secondly, it requires us to group things together, or in other words, to create what are essentially instances. An instance is a grouping that is specifically based on certain parameters. In this case, if we're talking about a material, we make instances based on a common template, that is, common shaders that were compiled for the parent material, Salve. Based on that, we then make copies, or instances. Therefore, a situation arises where we have a common denominator. In other words, there's something in common, a shared element between us, the users, and Unreal Engine. This shared aspect helps to connect both parties. What is it? It's creating material instances of the instance. We like this because, as we've already discussed, it's convenient, it's fast, and we like it. Unreal Engine likes it because it's already using compiled shaders and simply changes the values for the material instance based on them. So it works quickly, everything works quickly for us, we work quickly too, and we like all of that. Now, a question might naturally arise in your mind. Is it actually possible to create one big, gigantic, all-encompassing master material and then create various branches within it? No, you can't do that. And I'll explain exactly why that is. That's the wrong practice, the wrong approach to take. First of all, you might mistakenly think you can create these branches, for example, to specify whether this particular material is cloth, whether to use world position offset, or in other words, wind, whether to use this or that, and so on. In other words, making all sorts of branches. This creates a dilemma where every branch duplicates the shader. You need to understand that a shader and a material are two different things. A material is the whole thing, the material itself. We have nodes that branch our shader, meaning they branch the logic within the material to be either this or that. All of these branches, all of these switches, they create additional shaders, and shaders come into play when we apply the same material to different objects, to a static mesh, to Niagara, to, I don't know, a skeletal mesh, meaning a character. When you apply it, Unreal will automatically check a box here and enable the use of this material with the specific object you applied it to. Every checkbox, every option, every difference creates an additional shader. These shaders are called shader permutations. In other words, the number of shaders in general, for which platform you're making it, for a phone, for a console, for a PC, and for every one of these checkboxes for every option. So a lot of factors influence these permutations. In this case here, for example, with this incorrect material, as I mentioned, there's a checkbox for whether to use it with cloth and so on. In popular games like Fortnite, and I believe Black Myth Wukong, they generally stick to a range of 200 to 400 shaders. Right here, it will show the number of shaders, the shader count, which is the shader permutations. If you have between 200 and 400, or generally up to 400, then that's normal, everything is fine. Then of course, you'll naturally be tempted to create a large material and make various different branches from it. Because if you create an incorrect material like this, and then, for example, want to check a box here and say, this is for cloth, and then you switch to material overrides, you can redefine it, say, aha, this is cloth, and so on, you can easily fall into a trap. In these situations, exercising caution is especially important. The trap is that when you change it here, Unreal changes the entire algorithm. We already talked about this in the first videos. It changes the entire algorithm for how the material is calculated. This means it will weigh the same as the parent material, or even more. You don't need to override anything here. When you create something, you should do so by dividing all these master materials into specific categories. And this brings up the next question: what categories actually exist? The following categories exist. First, there are the types. The types are material domain, blend mode, and shading model, which I've told you about. For each of these types, and again, we talked about this in the first lessons, so watch those if you don't know. For each material domain, for each blend mode, and for each shading model, you should create a separate material, just a separate one. That's the first thing, the most basic level. Then for VFX effects, a developer usually splits the logic into parts. VFX effects mainly use additive materials. But for things like smoke or fire, you'd use translucent materials. And sometimes if you need distortion, for example, when making fire, you'll also want to add distortion to the combustion area, right? For that, you can create a separate distortion material. In the renderer, we have sprites, meshes, and so on, ribbons too. For each of these types, if you use them, you need to create separate materials for each one as well. This applies to flipbooks as well. And finally, you need to create master materials. In the end, what do we get? We get main, additional, and situational. The main one is opaque. All objects generally use this main opaque material. If we're talking about Megascans materials, then the entire landscape, all the grass and so on, these are seamless textures. We can stretch them infinitely however we want. Therefore, for them, we can say that we'd want to create a separate material with the ability to adjust the tiling, meaning the UV layout. So now we need to understand, if we're talking about something that can be tiled, something whose size we can adjust, let's look here. Here's my tiling. I can do it like this, like so, and make more tiles. Okay? If we're talking about something like that, you can create a separate one. Then we have translucent. It's mandatory for all translucent materials to have a separate master material. And in some cases, if your game doesn't involve creating complex shaders for glass, you can use the translucent material for glass. But if you have some kind of complex shader, a separate, large, sometimes bulky one for glass, then you need to create a separate master material for it. Then if you have vegetation, I'll remind you for vegetation, to ensure everything works correctly, we switch the blend mode to masked and also set the shading model to two-sided foliage in order to properly cut out areas that are not actually part of the texture. So, well, I will not talk about this for too long, but you just need to change these settings, make these adjustments, and then use it specifically for foliage. This is also, as you have probably gathered by now, a separate master material that is dedicated for foliage. Then, if you have a character, you use a skin master material instead. It is not always strictly necessary. You can use opaque materials as well, depending on your needs, if you have a stylized game or something similar to that. But if you're making a realistic one and you need to use profiles, then please use it. For fabrics, for unlit materials, a separate material is also used. Here we're talking about unlit, not for VFX effects, but in general. This is for things like light bulbs, some indicators, and so on. Basically anything that is self-illuminating. Then we have decals. So it turns out we need to divide our materials into these categories depending on what we need and what we don't need. Now, I just want to say one more thing. In reality, there are actually some unique cases where a certain material is so exceptionally unique and it's only ever used once. In that case, of course, it's applicable, it's permissible. In this case, I have such a material in my project. This particular material is truly unique, which means that I don't use this specific material anywhere else. It's a unique one-off case, and that's exactly why I created this simple, dedicated material just for it, and I use it only in this context. In such cases, it's applicable, meaning it's allowed to use separate materials, but only when they are truly separate, exceptional variations. I'm not going to go into details now because what I'm about to say, I've already said in the previous video. As you know, textures contain information in their channels. Each channel stores specific data, and we have an ORM texture, which means that each channel stores separate information about ambient occlusion, roughness, and metallic. We can use a breakout node to split it into 3 channels and use them. But between the texture and the split, I add this configuration of 3 nodes. I always use them for both ORM and for albedo. Why? Because it gives me control. First, as I've mentioned before, albedo, or what are called PBR materials, are limited to a range from 0 to 1. This means the values here cannot go beyond that range. Even if you exceed that value here, when you plug it in, it will be normalized back to the 0 to 1 range. Okay, dark pixels become noticeably brighter, while the bright ones that have already reached 1, their maximum brightness threshold, can't get any brighter than they already are. So, with this combination, we're simply adjusting the overall range of how bright each individual pixel can actually be. Next, I raise it to a power using a power node, which controls the contrast. I'm adding contrast. And finally, I adjust the brightness by multiplying to increase the overall brightness. I split it into channels and connect them to the corresponding attributes. And I do the same for albedo, or base color, as it's sometimes called. I add a separate desaturation node to control the saturation so I can remove the color, the hues, and I multiply it by a separate tint that I like. For the normal map, there's a control for the normal's intensity or its strength using this combination. And that's it. And finally, for the UVs, there's tiling. This separate combination for the UVs is used when I'm making something like a surface, as I mentioned, tiles and so on, like you see here. That's when I use this combination. As for substance, it's the same thing. Almost everything is analogous, except that this one has an emissive channel. But it's the same principle here. There's a switcher, a toggle, to decide whether to use it or not. It's called a switch param node, to use it or not, and then we multiply it by the brightness and just connect it right here. That's all. These are the most basic fundamental functions. So multiplication, power, multiply, of course divide, and of course subtract. We get that. We remember that. These are the most important, the most basic ones, okay? It turns out there's also add for addition. It adds a certain value. I've already told you that everything happening here is just us operating with numbers. I've explained this already, so again, I won't repeat myself. And right here, at this particular spot, it's actually not quite right. This is also considered a mistake, because if our texture happens to have an alpha channel, it really needs to be moved into a separate material.